Hi, I'm Yuki Miyazaki. I'm a solution architect for telecommunication company in Japan from AWS. I'm explaining about the network data twin as a graph for root cause analytics, powered with generative AI. So firstly, here is an entity DOCOMO challenge and background. So there is a demand for more stable mobile network services than ever before. In the other hand, their mobile network is now expanding and getting more complicated. So it's a huge challenge for entity DOCOMO to quickly identify faulty device even if it's in complicated situation. So here is an overview AWS solutions. The first one is end-to-end graph topology. End-to-end meaning it's not only the LAN, but also the transport network, but also core network. And also we add not only the inventory, but also the performance management data, fault management data to the topology. So then we can call the temporal graph topology by using their mobile network. The second one is graph analytics. So graph analytics is like a graph analytics algorithm, which is scoring the nodes, propagating failures. So this is for the root cause analytics. The third one is a proactive generative AI for the RCA reports. So then operator can talk to their network by generative AI with natural language. So the generative AI can understand what they want. Then generative AI query to the graph database and query to the result of the analytics. Then generative AI answer to their question. So this is entity DOCOMO's MVP architecture. The first one, the left side is like multi-vendor, multi-domain mobile network. They are collecting data from the access network, transport network to the AWS. So here is raw data, which is KPI, alarm data, and the inventory. Here is raw data. And this is a multi-data domain and the multi-network, multi-data formats. So we need to transform the raw data to the graph database format. So here is a data processing pipeline that we are using Glue and Lambda for the ETL. Then just stores all of the data to the graph database. And here is a root cause analytics pipeline. This is on demand. So when the critical alarms are detected, then root cause analytics is executed. So root cause analytics here, this is invoking graph analytics and stores RCS scores as a result and updates the result to the graph database. So for operators, they can see only their dashboard here. So in the dashboard, they can see what's going on and the result of the RCA. So now I'm showing the demo, 3 demo. The first one is Topology Explorer. The second one is RCA based on graph. The third one is a dynamic network graph. So this is the Topology Explorer, which is a built-in tool of Neptune Graph Database. Neptune Graph Database is AWS managed graph database services. And here is now we are now seeing the entity DOCOMO's actual production mobile network. The lowest layer is basement stations. Upper layer is a transport network. So now just clicking, then expanding the network. So now we can see, we can discover the end-to-end network topology. So also we can see the node list and edge list in the table view, like here. And just clicking to see the more details of the nodes, we can see the node information right side. We can see the node information like location information, IP address, something like that. And it's not only the static data, but also including the KPI data. It's dynamic changing. It's updated every 5 minutes. So now here, all of our KPI data. So we can call this, it's a dynamic topology. So by using Neptune Graph Database, the second demo is root cause analytics. When critical alarms are detected, then root cause analytics is executed in the background automatically. Now it's executing now. It takes only 15 seconds to identify the faulty device. Here is a result. So the highest score meaning the faulty device. in this case, Saitama M region router is a faulty device, and we can also see the yellow one is a faulty device in the subgraph. So this is the entity DOCOMO's mobile transport network. So there are more than thousands nodes here. So before this RCA, it was very difficult to identify the faulty device because there are so many alarms and so many nodes. There is more than 1,000 alarms. It was very difficult to identify. So, and we can see also the red node in the visualization tool. This is NTT DOCOMO's Japan nationwide mobile network. The third one is a dynamic network graph here. So dynamic changing the status of the node based on the performance management data. So we can see the node status like this on the visualization tool, red highlighted. And also we can see the basement stations under the one router here, like this. The fourth one is a generative AI for the operators. It can help operator to understand what's going on. So sometimes the operator cannot write down the graph query. So operator can ask what's the node status with natural language. Generative AI in the background, it's query to the Neptune graph database, and then the Neptune database answers the question to the operator. So it helps operator to understand what the status is and what the root cause is. So finally, this is the DOCOMO's benefits. So the first one, it's near real-time and high-precision RCA without requiring operation technical skills based on Amazon Neptune. And the second one is a visualization of dynamic topology for quick troubleshooting. The last one is end-to-end orchestration with seamless data pipeline by using Amazon Glue, AWS Lambda data processing service. So the biggest benefit is near real-time RCA, because before this RCA, it took a long time to identify the root cause. But now it takes only 15 seconds to identify the fault device. It is the biggest benefit for the NTT DOCOMO. So here is a targeted data tree architecture. It's more autonomous network. So I explained the high-level design. So here is a data pipeline. So raw data is coming from the device or OSS system to the AWS cloud. And here is a ETL pipeline, then stored here. So the operation data is like, it's huge. So for example, fault management data, performance management data, and network topology, configuration management data. And also we just put the network travel ticket. And by using this information, we can get more intelligent insight by using the graph deep learning and graph analytics. So then we can get the new data as a more intelligent data. And for operator can see the visualization tool and can ask to generative AI, depends on the use case. In the background, agent is here. So each agent can access to each data source, depends on the use case. So depends on what they ask or depends on the visualization. So agent can access to each data source. Then agent can summarize the status of the network or root cause the report. Then agent can answer the question to the operator or showing the result on the visualization tool. And the final one is this is a typical workflow, step by step to proceed the instrumental data tree. So the first one is discovery of network topology end to end. We can use Neptune database for topology and time stream data for the time series data. And the second one is a link prediction. Sometimes there is a missing data between the nodes. We can use Amazon Neptune machine learning to predict the link between the nodes to correct the perfect topology data. And then third one is a graph analytics algorithm, which I showed you demo. And fourth one is a forecasting. It's like a prediction of the performance data. For whole thing, generative AI can help operator to understand whole of thing. So this is a typical workflow to proceed the data tree. Thank you very much for listening.